Hello, everyone. Welcome to this session. My name is Saurav Das, and I'm a senior product manager here at Amazon Redshift. I'm going to do a deep dive into reliability features in Amazon Redshift, and this discussion is going to lead us to how you can achieve 99% fault tolerance with Amazon Redshift multi-AZ. We have a lot of content to cover, so let's get started. As you all know, tens and thousands of customers use Amazon Redshift every day to run data warehousing and analytics in the cloud. And these customers process exabytes of data for business insights. Amazon Redshift is a fully managed petabyte scale cloud data warehouse which was introduced in 2012, and we have been continuously innovating since then. There are four big areas of investment that drive benefits for our customers to help them achieve their business goals, as shown here. This session is going to focus on industry leading reliability features that are available to you at no cost. Given the strategic importance of data, analytic workloads are increasingly becoming mission critical, running 24 by 7, and any downtime leads to business loss. Some example use cases of mission critical workloads are financial institutions analyzing customer data to detect fraudulent activity, healthcare providers analyzing patient data to identify risk factors for chronic diseases, and the list goes on. This is the reason availability and reliability is very, very important for a modern data warehouse. So, before we dive into reliability features in Redshift, let's start by talking about some of our existing customer use cases. Janssen Pharmaceuticals, owned by Johnson& Johnson, uses Amazon Redshift to derive critical business insights to make important business decisions. Like other healthcare and life sciences companies, Johnson& Johnson also ramped up their analytics capabilities in the last 2 years to support their drug research and accelerate their fight against COVID. Amazon Redshift was at the heart of this process, requiring it to be highly available because any disruption delays critical business decisions. Let's take another example. Stripe is also using Amazon Redshift to power its in-house product for end users, which is Stripe Pipeline. Stripe's customers have been requesting highly available, reliable, integrated analytics solutions that can operate at scale, and Stripe Data Pipeline is the answer. Stripe Data Pipeline is an easy no-code solution that allows these customers to access all of Stripe data in Amazon Redshift. So I hope with these two customer use cases, I've made a very strong case for why reliability and availability is so important for your data warehouse. So now let's dive in and talk about some of these reliability features. First up, Amazon Redshift is a highly resilient cloud data warehouse. We support 3 nines SLA, which is ideal for most business critical applications. Redshift also has the ability to automatically recover from most software, hardware, and network failures. These are built in reliability features that automatically kick in as needed and no manual intervention is needed. Redshift Managed Storage, or RMS, has been a game changer for our customers. It allows our customers to automatically scale data warehouse storage capacity without adding any additional compute resources for both RA3 and serverless workloads. The storage system automatically manages the cache to deliver high performance equivalent to a local SSD. RA3 instances feature high bandwidth networking that reduces the time for data to be offloaded and retrieved. With RMS, which is backed by Amazon S3, there's no data loss because it's highly available and durable by default. RMS also automatically replicates data to all availability zones within the AWS region. Amazon Redshift also offers automated snapshots for provision clusters and recovery points for serverless at no charge, with limited retention period, and customers have the option to create paid user snapshots that can be retained indefinitely. For disaster recovery purposes, customers can replicate these snapshots to another AWS region of their choice. Customers can recover data or create copies from these snapshots on demand, either at the cluster or table level. This is a great option, but this approach requires application changes as the cluster endpoint changes for a recovered cluster. So, for such customers that do not want endpoint to change, cluster recovery across AZs is a great option. Customers can relocate a cluster in another AZ without losing any data or having to change their client applications. As the existing cluster fails over, a new cluster is created on demand in another AZ, and This feature is offered at no additional charge since the cluster is created on demand and only one cluster is running at any point in time. The cluster's endpoint remains the same after relocation occurs, so applications can continue operating without any modifications. The feature is opt-in for RA3 instance family, but enabled by default for serverless workloads. Redshift Managed Storage also ensures RPO is zero with no data loss. As you can see, Amazon Redshift supports many reliability features, but these features are not suited for customers with mission critical workloads. These customers demand higher availability and even lower RTOs, that is within seconds, to avoid any downtime. To meet the demands of such mission critical workloads, we introduced multi AZ deployments, which is in preview, and we've been receiving feedback from customers such as yourselves. Multi AZ deployments for provision RFE clusters support running your data warehouse simultaneously in multiple availability zones, and it can continue operating in unforeseen failure scenarios. Multi-AZ deployments reduce recovery time to tens of seconds, typically under a minute, by automatically failing over your entire data warehouse to another AZ in the unlikely event of an AZ or infrastructure failure. RPO is zero because it is backed by Redshift Managed Storage. Since multi-AZ cluster is managed as a single data warehouse with one endpoint, it can maximize query throughput by using compute resources from both AZs. And there are no application changes needed to maintain business continuity. This part is pretty much the same as the cluster relocation feature. Now, let's briefly talk about how a multi-AZ cluster reduces recovery time during an AZ or infrastructure failure. On your left is a multi-AZ cluster with 4 nodes, signified by the orange dots in each AZ, AZ1 and AZ2, where AZ1 is the primary AZ and AZ2 is the secondary AZ. The cluster has a total of 8 nodes that are all part of the data warehouse sitting behind a single cluster endpoint, and the compute from all 8 nodes gets used at all times because queries are routed to each AZ in a round robin fashion. Let's say you experience an unlikely event such as an AZ failure on AZ1. When this happens, your multi-AZ cluster will fail over to AZ2, which is the new primary AZ. During the failover process, all active connections on AZ1 will be dropped and any in-flight transactions will be aborted. New connections can be resubmitted immediately and will be routed to a healthy AZ, that is AZ2, within a few seconds, typically under a minute. Additional compute nodes will be provisioned in AZ3 to always maintain posture in 2 AZs. The key thing to note here is that the reduced recovery time and that the capacity is guaranteed since it's pre-provisioned with multi-AZ. There's no duplicate storage cost as storage is shared through Redshift Managed Storage. You incur additional compute charges in the secondary AZ, but that compute is always being actively used and it's not sitting idle as a standby resource as we've seen with many other solutions. Okay, now for the fun stuff, which is the demo. So let's get into a demo. I'm going to show you how to create a multi-AZ cluster and its various features. We are also going to simulate an infrastructure failure and measure recovery time. I'm on the Amazon Redshift clusters page, and since multi-AZ is in preview, so I'm going to use the create preview cluster link to create the multi-AZ cluster. So let's click on this. Over here, I'm going to say multi-AZ demo. So this is what I'm going to give the cluster as the name. I'm going to choose the preview track, which is preview 2022. And then I'm going to select a small instance type just to save some costs here. And then I'm going to say multi-AZ deployment as yes. And you see the moment I do that, the configuration summary changes. It tells you how many nodes. So if you have 2 nodes per AZ, this is going to be 4 nodes overall because 2 per AZ. I'm going to load some sample data, and then I'm also going to auto-generate the password. Actually, let me just enter the password. Okay, so I've selected a password, I've done that, and then over here, instead of using defaults, I'm going to come here and go to the database configuration and customize the encryption setting. and I'm going to select one of the KMS encryption keys, which I already have. This is needed because multi-AZ requires encryption. That's mandatory, so you need to specify a KMS key to encrypt your cluster. Now I'm going to create the cluster, and this is going to go on, so you're going to see the progress on the top. Now, we're not going to wait for that in this demo. So for the purpose of demo, I already pre-created a multi-AZ cluster by this name. And you can see this is a multi-AZ cluster because this column here says yes. And then these are the availability zones where it's deployed. This is just like your preview multi-AZ clusters, which you can also create. So I've created this on the preview track, as you can see over here. So let's go inside the cluster overview page over here. And once you go here, even in the general information section, we have a way for you to find out if the cluster is multi-AZ or not. Over here is your cluster endpoint information, which you probably already know about. If you want to find out the AZ information, it's also available in the properties section, where in the availability zone, it tells you which is the primary availability zone, which is the secondary availability zone. You can scroll down further and get more detailed information about the nodes, which are part of the multi-AZ cluster configuration, their IP addresses, and the availability zones distribution. Anyways, so with this, I think we want to get started and do a failover. So for that, what I've done is, before we do that, I have here two terminals, and I'm logged into an EC2 instance, and I'm going to go and connect into this cluster. So I have the cluster connection string over here. This is the name of the cluster, and then I'm going to try and connect into this cluster. So I'm going to enter the password, and there it is. So I'm there. So I'm going to look in as what are the schemas and the tables over here. So I like the name of the table over here. What I'm going to do is I'm going to just issue a simple query, which is count of star on this table, and see how many rows it has, right? So very simple. So it has 11 rows, right? Now with that, I have this active session over here. I'm going to go and issue a failover. And you can do that through this button over here. I also have a timer here, which I can use. So the moment I kick off this failover, I'm going to start the timer. So anyway, so let's kick off the failover. The first thing is you're going to see there's going to be a warning. It's going to tell you what this is doing. It's simulating an actual failure. So I'm going to say confirm, and right away I'm going to start the timer. So over here you can see the timer has started. Now let's go back to our session and try and reissue these queries and see when they fail. And so far it is succeeding and right over here you can see that the queries have stopped. So about 15 seconds in, it's done. So I'm going to start, I'm going to try and connect this cluster again over here. So I have the connection string set up, and you can see it prompts me for the password, and within 30 seconds I'm back into the cluster, right? So and you see the query is going to succeed here. There you go, right? So I'm just going to pause the timer here. It doesn't make sense. Now you're going to notice one thing over here. The cluster state is still modifying. So what's happened is the primary AZ compute has failed over. The secondary AZ compute is still not available. That takes a little bit longer, a few more minutes, and that's when we're going to change the status to available. But the primary goal here is to restore availability quickly within a few seconds, typically under a minute. I think we have done that. Okay, so we're done with this session. Thank you for watching.